Hi everyone, my name is Allison Taylor and today I'll be presenting on the Physics 2212 Lab 2. So just a little bit of introductory information. This lab is called Lines of Charge, and some of the fundamental concepts we're going to talk about would be Coulomb's law, the fact that electric charge is conserved, how the sum of net forces on a system at equilibrium is zero, and we're looking into what is the best way to model certain electric fields. And so just a little bit of insight into the conclusion is that the line of charge is greater than the point charge method. So purpose and procedure for this lab, the purpose was to determine the amount of excess charge on one piece of tape and compare the different ways of modeling to the situation that was happening in GlowScript. We also wanted to observe and record the interaction between the two pieces of tape have on each other on a physical level. So based on the Lab 1 procedural steps, we placed one piece of tape, sticky side down on a desk, placed another U-tape on top of it, quickly removed to make a U-tape, and then using different objects we determined the charge, and also levitated a separate piece of tape labeled tape B to determine the forces that would be acting on it. So some of my calculations are shown here. Just to clarify, there are new assumptions in comparison to Lab 1. In Lab 1, we assumed that the tapes could be treated as point charges. However, this time we are assuming each piece of U-tape has the same net charge distributed throughout. The system in this instance is the tapes, while the surroundings is everything else. And we also ignore air resistance. As you can see, my data is a length of 0.2 meters, a mass that is associated from that of 2.03 times 10 to the negative 6 kilograms, leading to a gravitational force of 1.99 times 10 to the negative 5 newtons, and the distance of levitation was 0.14 meters. However, this could be a potential source of slight error as the levitation occurred so quickly and the ruler could be too far away to accurately read. So in terms of potential sources of error, the distance measurement could be slightly off. So here is my GlowScript. I started with the coding the green box, which was calculated in Lab 1. That's including the mass and charge, along with the vector position and the top tape line of code circled in the purple circle. That is also from Lab 1. Then the function E field in the yellow box is used to implement Coulomb's law, while the code in the red box can integrate through each piece of tape to get the total charge across its length. Here are a few of my GlowScript results, my one GlowScript result from Lab 2 off to the right. The GlowScript result off to the left is from Lab 1. I just included it for comparison purposes. So in the GlowScript, we solved directly for the magnitude of the electric force, and that came out to be 3.82 negative 4 newtons from GlowScript. Then we used Coulomb's law to rearrange, and were able to find the charge of the tape using the line of charge model to be 2.51 e to the negative 8 coulombs. And as you can see, I have also listed the charge of the tape as a point charge from Lab 1 as 7.04 e to the negative 8c. So some of the questions that I was to answer is, what if you had modeled each type of your tapes as a single point charge like in the previous lab? And I went ahead and said that the value of the line charge is smaller than that which was calculated using the singular point charge model. And why do these estimates differ? Well, the line charge, though smaller, is more accurate, as integration across the entire tape will provide more data points and a more accurate average electric force. The charge is not just concentrated in the center, but spread out throughout the tape as modeled by the line charge. And finally, the purpose of this lab, just to wrap up the conclusion, was to observe the way point charges interact with each other in order to better understand repulsion and discover whether the line charge model of multiple point charges in a line was more accurate than single point charges. And then also for the tapes to levitate vertically above the other charged piece, the force of gravity and the force of the electric field had to be equivalent, Using this information, we then used Coulomb's law and the equations to calculate electric properties of the tapes. Thank you very much.